In this video, we will solve a beautiful and famous zeta-gamma integral. The goal is to evaluate the integral from 0 to infinity of x times natural log of x, divided by e to the x minus 1. We'll do this step by step and connect it to the gamma function and the Riemann zeta function. Let's write the integral clearly so we can focus on the structure. The key idea is to expand 1 over e to the x minus 1 as a geometric series. Then we'll integrate term by term. Now substitute that series into the integral. We can interchange the sum and the integral because the series converges nicely for positive x. This gives a sum of simpler integrals. Now we need to evaluate the integral of x times natural log of x times e to the negative nx. This is where the gamma function appears. First, recall the basic gamma integral. If we differentiate with respect to s, we bring down a natural log of x. Our integral has e to the negative nx instead of e to the negative x, so we use a scaling substitution. Let u equals nx. A more compact way is to use the identity. The integral of x to the s minus 1 times e to the negative nx equals gamma of s divided by n to the s. Then differentiate with respect to s. Our integrand has x to the first power, so we set s equal to 2. That gives x to the s minus 1 equals x. Now sum over n from 1 to infinity. This creates two famous series. The sum of 1 over n squared is zeta of 2, and the sum of log n over n squared is negative zeta prime of 2. So we can write the answer using zeta functions. Substituting these identities gives a clean expression. Now, let's evaluate the gamma pieces. Gamma of 2 is 1 factorial, which equals 1. Gamma prime of 2 equals gamma of 2 times digamma of 2. Digamma of 2 equals 1 minus Euler's constant. We also know zeta of 2 equals pi squared over 6. So the exact result is, if we want a numeric value, zeta prime of 2 is approximately negative 0.937548. So the integral is approximately negative 0.243. Let's summarize the key ideas. We expanded 1 over e to the x minus 1 as a series. Then we used the gamma function and its derivative to evaluate the integrals. Finally, we recognized the zeta function and its derivative. This gives an elegant closed form involving zeta prime of 2 and Euler's constant. That's the full solution to the zeta-gamma integral.
Don't forget to like this video, share it with your friends, and subscribe to Knowledge Station. Thank you for watching.